Before we look at object orientation in any depth, I just want to talk a little bit about the theory of object-oriented programming, or OOP for short. And so I want to start explaining how you can create your own objects and how you define those objects based on type definitions called classes. The definition of an object is called its class. You can think of a class as a blueprint for an object. It's just like the blueprint of a car. The blueprint defines all the fundamental features of a car, but you can't actually drive the blueprint. To use a car, you have to create one based on the blueprint's definition, and that's what you do in programming too. You write a class and you create usable objects from it. In fact, just as you can create many cars based on a single blueprint, so you can create many objects based on a single class. Now you can write all sorts of different programs using object-oriented techniques. For example, let's suppose you want to write an adventure game. Now, what you see here is a game I wrote many years ago, long before Delphi or Object Pascal were available. And this was written, in fact, in an old version of Pascal, the predecessor to Delphi, really, called Turbo Pascal. And I didn't have objects available to me, and it was really quite frustrating in a way, because I was working with essentially a program that demanded objects. The adventure game is full of objects. It's got rooms which are objects, and it has characters, it has treasures. And so this is a perfect example for the sort of program that would really benefit from using object-oriented techniques. So let's consider how you'd go about designing an adventure game using object orientation. I've decided that everything in my game, that's all the treasures, rooms and other objects, will have a name and a description. So I start out by defining a basic thing class, with variables and methods required to handle the name and the description. And I can create from this thing class any number of individual thing objects, each of which has its own name and description. So now I decide I need a separate treasure class and also a room class, and these will be the blueprints from which individual treasure and room objects can be created. These two have names and descriptions. But since I already have a class that handles those, I decide that I make both the treasure and the room class as descendants of the thing class. Now this is one of the key features of object orientation. You can create a simple class and then define other classes, more complicated classes, that inherit all the features of the simple class and add on new features of their own. So that means I don't have to recode the same features over and over again. Now the treasure inherits everything that's already defined in the thing class. Here that's its name and its description. All I have to do now is add on any extra data or behavior that's specific to treasures. So here I give the treasure a value. Now even though I've only coded one specific new feature, that's value, in the treasure class, it actually has name, value, and description. It's just inherited name and description from its ancestor class, thing. And the same is true of the room class. It also descends from thing, so it automatically gets a name and a description, and it adds on one extra feature. And in this case, that's the exits of the room. Now when I talk about features in real code, these might be a combination of data, variables, and behavior, that's methods. And I can carry on creating further levels of subclasses. Here, weapon descends from treasure. It inherits the name, description, and value, and it adds on destructive power. Meanwhile, the jewel class descends from treasure too. So it has a name, description and value as well, and it adds on one more feature, type of gem. So now this is the situation. I have a jewel and a weapon which are special types of treasure. I could say that the jewel, the weapon, and the treasure classes are also special types of thing, because the thing class is their ultimate ancestor. And I can go on to create other lines of descent. For example, here the vault class descends from room, so it inherits name, description, and exits. And it adds on combination lock. The vault class does not descend from treasure, however, so it doesn't have value, nor does it have any of the special features of the descendants of treasure, such as destructive power or type of gem. And now, with all these classes to choose from, my program can create objects based on all these different types of class blueprints. Thing objects, treasure objects, weapons, jewels, rooms, and vaults. The real power of object orientation will be more obvious when we look at how to create hierarchies of objects, classes that define different types of base class. Here, for example, you can see I've got a book object class, and I define descendants which add on extra features to the basic book ob. So there's a horror book ob and a ref book ob for reference and horror books. And I'll look at that later on. But this is already a bit too complicated to start with. It's just like the adventure game example. It introduces too much of the complexity of object-oriented programming, and so initially I want to simplify things, and shortly I'm going to look at a much simpler object-oriented project which just considers the CD database that we used in a previous project, and then we used a record. Well, this time I'm just going to look at the basic syntax you'll need to implement a similar sort of program, but this time defining CD objects, which are based on a class definition instead of a record.